Hello students, in previous lecture we have seen the geometrical meaning of derivative and derivative of inverse function. Now today we have seen the derivative of inverse trigonometric function. In inverse trigonometric function, first result is if y is equal to sine inverse x, the condition for x is -1 to 1. That means x lies in between enclosed interval -1 to 1 and y lies in between enclosed interval -pi/2 to pi/2. Then prove that dy by dx is equal to 1 upon under root 1 minus x square such that the determinant of x is less than 1. This is the derivative of sine inverse of x. Now we have seen the proof of this result. Here given statement is y is equal to sine inverse x and the condition for that x is lies in between -1 to 1 and y is lies in between -pi/2 to pi/2. Here y is equal to sine inverse x, then we can express this is in the form of x is equal to sine y and differentiate this function with respect to y. Then dx by dy is derivative of sine y with respect to y is cos y, and we write this cos y function in the form of x. Hence take the value of cos y is under root cos square y, and then take add an addition and subtraction sign here. Uh, Therefore, the cos square y is under root 1 minus sine square y, and sine square y is x square. Here put the value of sine square y. Hence dx by dy is plus minus under root 1 minus x square. But cos y is positive since y lies in first quadrant or fourth quadrant, as y lies in between -pi/2 to pi/2. Hence our differentiation dx by dy is under root 1 minus x square. It is positive because cos y is lies in the first or fourth quadrant. In last lecture we have seen that expression dy by dx is equal to 1 upon dx by dy. Therefore dy by dx is 1 upon under root 1 minus x square. Just we take this dx by dy in the formula of dy by dx is equal to 1 upon under root 1 minus x square. Here mod x is less than 1. Now second result is y is equal to cos inverse x. Here x lies in between -1 to 1 and y is lies in between 0 to pi. Then the prove that dy by dx is equal to -1 upon under root 1 minus x square. Student, this proof is homework for you because you try to solve this theorem. This theorem just like as the sine inverse result. Okay, now prove that as homework. Now next third result is y is equal to cot inverse x. Here x belongs to r. R means a real number and y lies in between 0 to pi. That means y lies in between open interval 0 to pi, and our differentiation expression is y is equal to cot inverse x. We can write this is in the form of x is equal to cot y. Take this equation number 1. Differentiate this x with respect to y. We get dx by dy is derivative of cot y with respect to y is minus cos x square y, and we express this cos x square y in the form of 1 plus cot square y because the value of cot y is x, and here we express this differentiation in the form of x. Therefore dx by dy is minus in bracket 1 plus x square. In last lecture we have seen The result dy by dx is equal to 1 upon dx by dy. We just take here the derivative of dx by dy and we find out the cot inverse x, derivative of cot inverse x. Therefore, dy by dx is equal to 1 upon minus 1 plus x square. This is the derivative of cot inverse x. Now, next result is if y is equal to tan inverse x, here x belongs to real number and y lies in between enclosed interval minus pi by 2 to pi by 2, then dy by dx is 1 upon 1 plus x square. Students, this result also left as the homework for you. You just open your textbook and see the result of this tan inverse x in the textbook. Okay, now next result is if y is equal to sin inverse x such that mod of x is greater than or equal to 1 and y lies in between 0 to pi. That means y lies in closed interval 0 to pi and y is not equal to pi by 2, then dy by dx is 1 upon x into under root x square minus 1 if x is greater than 1 and dy by dx is equal to minus 1 upon x into under root x square minus 1 if x is less than minus 1. See the proof. Given that y is equal to sec inverse x and we express this expression in the form of x is equal to sec y. Take this equation number 1 and differentiate this with respect to y. Then derivative of cos sec y is sec y into tan y. And we express this tan y in the form of sec because sec y is x, hence tan y is written as under root tan square y and tan square y is sec square y minus 1. Then dx by dy is plus minus x into under root x square minus y. Just here put the value of sec y is x, hence dx by dy is plus minus x into under root x square minus 1 and dx by dy the value for x into under root x square minus 1 when x is greater than 0 or the condition for dx by dy is equal to minus x upon into under root x square minus 1 when x is less than minus 1. If x is greater than 1, then derivative of dy by dx is 1 upon x into under root x square minus 1. And if x is less than minus 1, then derivative dy by dx is minus 1 upon x into under root x square minus 1. Now next result is if y is equal to cosec inverse x such that mod x is greater than or equal to 1 and y lies in between minus pi by 2 to pi by 2, then dy by dx is minus 1 upon x into under root x square minus 1 if x is greater than 1 and dy by dx is equal to 1 upon x into under root x square minus 1 if x is less than minus 1. Students, this result also left as homework for you. We are seeing the examples on the result. Differentiate the following functions with respect to x. Here example is sin inverse x cube. This function is in the form of composite function or function of function and this function is called as chain rule. We use here chain rule. Let our function y is sin inverse x cube and differentiate this function with respect to x. We get dy by dx is equal to derivative of sin inverse of x cube with respect to x is derivative of sin inverse x is 1 upon under root 1 minus x square. We use this formula here 1 upon under root 1 minus x cube raised to 2 into derivative of x cube, because here we use the chain rule, or this is the composite function or function of function. Hence we take the derivative of x cube. This here next step is 1 upon under root 1 minus x raised to 6 into derivative of x cube is 3x square. Therefore, dy by dx is 3x square upon under root 1 minus x raised to 6. This is our derivative. Now, next example is y is equal to cos inverse 2x square minus x. Here, we express this function in the form of cos y is equal to 2x square minus x, and take this equation number 1. Differentiate this function with respect to x. Hence, the derivative of cos function cos y is minus sin y, and derivative of y is dy by dx, and derivative of 2x square minus x is 4x minus 1. dy by dx is 1 minus 4x upon sin y. In this expression, we just replace this sin y into right side. Hence, our differentiation dy by dx is 1 minus 4x upon sin y, and this sin y is expressed in the form of cos function because cos is x. Hence, we write it as dy by dx is equal to 1 minus 4x upon under root 1 minus cos square y. Therefore, dy by dx is equal to 1 minus 4x upon under root 1 minus x square into 2x minus 1 bracket square. From this expression from equation 1, and the alternative method of this function is if y is equal to cos inverse 2x square minus 1, and we know that the derivative of cos inverse x, the derivative of cos inverse x is minus 1 upon under root 1 minus x square. We just use here the formula for cos inverse x. Hence, differentiate this function with respect to x. Our dy by dx is take derivative cos inverse 2x square minus x with respect to x. It is minus 1 upon under root 1 minus 2x square minus x raised to 2 into derivative of 2x square minus x, because here we use the chain rule or composite function. Hence, we take the derivative of 2x square minus x, and derivative of 4x minus 1 is 2x square minus x is 4x minus 1. Therefore, dy by dx is 1 minus 4x upon under root 1 minus x square into 2x minus 1 its square. Now, next question is differentiate the following function with respect to x, and the function is cos inverse in bracket 4 cos cube x minus 3 cos x. Now, see the solution of this function. Let this function is as y is equal to cos inverse 4 cos cube x minus 3 cos x, and this bracket function is, this is the expression of or formula of cos 3 theta. Hence, we take formula for cos 3 theta here. Therefore, function y is cos inverse of cos 3x. Here, cos 3x is in the principal domain of cos function. Hence, y is equal to 3x. Differentiate this function with respect to x. We get dy by dx is equal to derivative of 3x with respect to x is 3. Hence, dy by dx is 3. Now, next example is sin inverse of under root 1 minus cos x upon 2. Let this is y is equal to sin inverse of under root 1 minus cos x upon 2, and we write here the formula for 1 minus cos x is 2 sine square x by 2 and 2 get cancelled. The under root of sine square x by 2 is sine x by 2. Hence, our y function is sine inverse of sine of x by 2, and here x by 2 is in the principal domain of sine function. Hence, y is x by 2. Differentiate this y with respect to x, we get dy by dx is equal to derivative of x by 2 with respect to x is 1 by 2. Hence, dy by dx is 1 by 2. This is our solution of the given function. Now, next question is differentiate the following function with respect to x. Here, given function is sine inverse of 2 cos x plus 3 sine x upon under root 13. Here, just we let this function as y is equal to sine inverse 2 cos x plus 3 sine x upon under root 13. Just here we separate this term 2 under root 13 into cos x plus 3 under root 13 into sine x. These values are given very well, and proper arrangement of the formula. Just here put the value of 2 upon under root 13 is sine alpha and 3 upon under root 13 is cos alpha. Because the squaring these values and adding, we get the solution is 1. Hence, sine inverse alpha plus cos inverse alpha is equal to 4 upon 13 plus 9 upon 13 is equal to 1. And just here the take a ratio of sine alpha and cos alpha is 2 by 3. Root 13 get cancelled. Hence, tan alpha is 2 upon 13. Therefore, alpha is equal to tan inverse of 2 by 3. Hence, we express our function in the form of y is equal to sine inverse of sine alpha into cos x plus cos alpha into sine x. Hence, y is equal to sine inverse of sine x into cos alpha plus cos x into sine alpha, and this is the formula for sine x plus alpha. Hence, we write this is in the form of sine x plus alpha. Therefore, function y is sine inverse of sine of x plus alpha, and here the x plus alpha is in the principal domain of sine function. Hence, we write it as y is equal to x plus tan inverse 2 by 3. And here we just the take for value of alpha is tan inverse 2 by 3. Now, differentiate this function with respect to x is dy by dx is equal to derivative of x plus tan inverse 2 by 3 with respect to x, and this is the constant term and derivative of x is 1 and constant derivative is 0. Hence, dy by dx is 1. This is the solution of the given function. Now, next example is differentiate the following function with respect to x, and our function is sine inverse 2x upon 1 plus x square. Let this is y is equal to sine inverse of 2x upon 1 plus x square. Here see properly put the value of x is equal to tan theta. Why we put here x is equal to tan theta? Because in this expression or in this bracket term, in trigonometric function, the formula for tan theta is in the form of 2 tan theta upon 1 plus tan square theta. This is the formula for sin 2 theta. We can use here the formula for sin 2 theta. Hence, we put the value of x is equal to tan theta. Therefore, theta is equal to tan inverse x. And function y is sine inverse of 2 tan theta upon 1 plus tan square theta. Therefore, y is equal to sine inverse of sine 2 theta, because this is the formula for sine 2 theta, and this 2 theta is in the principal domain of the function y, sine function. Hence, our function y is 2 theta, and we put the value of theta is tan inverse x. Hence, y is equal to 2 tan inverse x, and differentiate this y with respect to x, we get dy by dx is equal to 2 into derivative of tan inverse x with respect to x, and we know that the derivative of tan inverse x 1 upon 1 plus x square is the derivative of tan inverse x. Hence, dy by dx is equal to 2 upon 1 plus x square. Now, next example is tan inverse 2 e raised to x upon 1 minus e raised to 2x. Now, see here, let this is the y function. Y is equal to tan inverse 2 e raised to x upon 1 minus e raised to 2x, and we put the value of e raised to x is tan theta. Hence, again this is the form of tan expression in the tan expression. Hence, theta is equal to tan inverse e raised to x. Therefore, y is equal to tan inverse of 2 tan theta upon 1 plus tan square theta, and this is the formula for tan 2 theta. Therefore, y is equal to tan inverse of tan 2 theta. Hence, y is equal to 2 theta, and here just we put the value of tan theta is tan inverse e raised to x. Therefore, y is equal to 2 tan inverse e raised to x. Differentiate this function with respect to x. Therefore, dy by dx is equal to 2 upon 1 plus e raised to x square into derivative of e raised to x, because again this is the composite function or function of function. Hence, dy by dx is 2 e raised to x upon 1 plus e raised to 2x. Here, the derivative of e raised to x is e raised to x. Hence, dy by dx is 2 e raised to x upon 1 plus e raised to 2x. Therefore, this is the solution of the expression, given expression. Now, next a question is differentiate the given function with respect to x, and first example is tan inverse of 4x upon 1 plus 21 x square. Let this is the y. Y is equal to tan inverse of 4x upon 1 plus 21x square, and see properly here, we express this bracket in the form of alpha minus beta upon 1 plus alpha into beta. This is the formula for tan inverse of alpha minus beta upon 1 plus alpha into beta is equal to tan inverse of alpha minus tan inverse of beta. Therefore, we express this term very carefully, because here the value is 4x and 7x minus 3x is 4x, and the multiplication of 7x into 3x is 21x square. Hence, we take the value of alpha is 7x and the value of beta is 3x. Now, we can write this expression in the form of tan inverse of 7x minus 3x upon 1 plus 7x into 3x. And this is the formula for tan inverse of 7x minus tan inverse of 3x. And differentiate this with respect to x, we get dy by dx is equal to derivative of tan inverse of 7x with respect to x minus derivative of tan inverse 3x with respect to x, and the derivative of tan inverse x is 1 upon 1 plus x square. Hence, we just use the formula for tan inverse x here, 1 upon 1 plus 7x square into derivative of 7x with respect to x minus 1 upon 1 plus 3x square into derivative of 3x. because again this is the chain rule. Therefore, dy by dx is 7 upon 1 plus 7x square and minus 3 upon 1 plus 3x square. Just here the derivative of 7x is 7 and the derivative of 3x is 3. Hence, dy by dx is 7 upon 1 plus 7x square minus 3 upon 1 plus 3x square. Now next example is y is equal to tan inverse of 7x upon 1 minus 12x square is tan inverse of 4x plus 3x upon 1 minus 4x 3x. Here we express this bracket term in the form of alpha plus beta upon 1 minus alpha into beta. Here 4 plus 3x is 7x and the multiplication of 4x into 3x is 12x square. Hence, we can express this bracket in this form alpha plus beta upon 1 minus alpha into beta. This is 4x plus 3x upon 1 minus 4x into 3x, and this is the formula for tan inverse of 4x plus tan inverse of 3x. Differentiate this function with respect to x. dy by dx is derivative of tan inverse of 4x with respect to x plus derivative of 3x with respect to tan inverse of 3x with respect to x, and just use here the formula for tan inverse x 1 upon 1 plus 4x square into derivative of 4x, because this is a function of function, plus 1 upon 1 plus 3x square into derivative of 3x. Here again this is the function of function, hence differentiate this 4x with respect to x, it is 4, and derivative of 3x with respect to x is 3. Hence, dy by dx is 4 upon 1 plus 4x square plus 3 upon 1 plus 3x square. This is our solution of the given expression. Students, today we stop here, and in next lecture we will see the logarithmic differentiation. Okay, stop here.